Chapter 9, Section 6 in the 8th grade note-taking guide is entitled Displaying Data. So what we've been looking at are graph types that display the actual values of a data set or some of the actual values of a data set. Now we're going to head back to the graphs that we know and love, the ones that don't really actually display the values of the data set. They display accumulations of the data set, totals, what we get when we add up the things of the data set. That's really what we get here with these types of graphs that we're going to be looking at here. So what graphs are we looking at here? Double bar graph. That's a graph that uses vertical or horizontal bars to display two sets of data. A graph that uses vertical or horizontal bars to display two sets of data. A frequency table is a table that lists items according to the number of times or frequency that the items occur. A table that lists items according to the number of times or frequency that items occur. A histogram is a bar graph that shows the frequency of data within equal intervals. It's a bar graph that shows the frequency of data within equal intervals. Now what you have to know is these two graph types here in the middle, those actually go together. The frequency table comes with the histogram. Now you can actually have a frequency table that stands on its own, but don't try and make a histogram without making a frequency table. And you'll see that here in a minute. But again, frequency table can stand on its own, but a histogram, you have to make the frequency table before you get there. All right, so with that out of the way, let's go ahead and look at the last definition here, a double line graph. A double line graph is a graph that uses line segments to show how two related sets of data change over time. A graph that uses line segments to show how two related sets of data change over time. And we've seen that before. Again, notice here they really are avoiding the single bar graph and the single line graph. They believe by this point in time you should have a firm understanding of that. So they're not really going to spend any time on that at all whatsoever. They're really going to spend time focusing on the doubles. Alright, so let's go ahead and take a look here at example 1. They're asking us to make a double bar graph here. Alright, it says here, the following are the number of books read in 1 month by some boys and girls in grade 8. And we're supposed to make a double bar graph of that data there. So as you can see here, we've got one set of bars in my graph that represents boys, which is this first whole column listed down here in the key, and a second whole set of data here represented by girls, which is represented by a different type of bar in the key there. And so that's what we're going to end up graphing here. So we're going to come down to our graph here. Now I want to make sure I point out that this graph has all the properties of a well-prepared graph, everything it should have before we actually start looking at the graph. It has a title. Your graph should have titles. It does have labels on both the X and the Y axis. That is essential. Because these graphs here, other than the histogram, are going to be doubles, you do have a key here. The fourth property of a well-prepared graph that you're already well aware of because we've talked about it many times is neatness. That's inherent with these computer drawings. So we're going to go ahead and set up our graph. As we can see, this data set goes from 0 to 5. So we're graphing on the x-axis everything from 0 to 5. Up the y-axis is going to go my frequencies. As you can see, my numbers go all the way up to 4 here at the most. So our graph has to hit or go over 4. As you can see, it does go up exactly up to that point. And once we set that up, we can go ahead and start graphing. So as you can see, for the number of books read at 0, boys and girls bars are both at 2. So both those bars are drawn up to 2s, and they cap those out right there. For the 1 bars, and you can go through the list here, 3 for the boys, 1 for the girls. So as you can see, the boys bar is much taller than the girls bar because the boys bar tops out at 3, whereas the girls bar tops out here at 1. And you can go down the list continuing to graph. What I want to make sure you note though here is there's space in between each category's bars. Bars for 0 don't touch the bars for 1. The bars for 1 don't touch the bars for 2. The bars for 2 don't touch the bars for 3, and so on. That's the proper way to make a bar graph. If the bars touch, you're actually making something else here. What can touch are the bars in each category. The bars for 0 in boys and 0 in girls, those can touch. That's not a problem as drawn. But they cannot touch the bars for 1. They need to have separation there. When those bars touch, you're ending up making something like a histogram that you'll see in a minute here. All right, and with that said, let's go ahead and take a look at number 2, that histogram. It says Jimmy asked 12 children how much money they received from the Tooth Fairy. Use the data to make a histogram. Now the graph over here is the actual histogram over here. This is the histogram. This here is the frequency table. You have to have the frequency table before you can make the histogram. This can stand alone, as I said in the introduction. You can have just a standalone frequency table. You cannot, however, have a standalone histogram. You have to make this before you get this. What's important about this frequency table here is this left column. When you make a frequency table, you have to have even-sized intervals, which is something they talk a whole lot about here. And indeed, we do have even-sized intervals here. Each interval is the size of $1. Now, some of you might be saying, well, wait a minute, 0 to 99 cents, that isn't a dollar. Yes, actually, it is a dollar, because realize if I count the 0 amount, all right, and then go up from there to 99 cents, that's actually a whole dollar of values when we include that, that 0 cent amount. So each set here is a dollar. Now, did they absolutely have to choose a dollar? No, absolutely not. They did not have to choose a dollar. That would not have been a big deal. So they could have chosen to start with 0 to 49 cents. And then the next one could have been 50 to 99 cents. And then they would have just been choosing increments of 50 cents. It doesn't matter what you pick as long as all the groups are of the same size. All right. But let's go back to the question at hand here. They decided they wanted to use dollar groupings here, so that's what they used. So they went through and they figured out what each number set belong, what interval there rather each set belongs into. So if we take a look here, we can go through. 35 cents belongs in the 0 to 99 cents group. $2 belongs in the 2 to 2.99 group. 75 cents belongs in the 0 to 99 cent group. $2.50 belongs in the 2 to 2.99 group. And as you go through the whole list, you're going to see that there's 4 numbers in the 0 to 99 cent group, 3 in the $1 to $1.99 group, so on and so forth. That's how you make your frequency table. But again, what's of utmost importance there are the even-sized groups. If you don't have the even-sized groups, it's not going to work. All right, so now as far as making the graph goes, we can come over here and make the graph just like we'd make a bar graph. It's much the same. Again, the only difference here is the bars actually touch each other. The bars from the first category to the second category to the third category to the fourth category touch each other. You won't have a double histogram, so you don't have to worry about a legend or a key. So we're making my graph with these categories on the x-axis and these numbers being represented on the y-axis. Since the graph is only going up to 4, they just went up by 1s, and they made a bar of roughly equal width for each set there. So the 0 to 99 cent group goes up to 4 on the graph because there's 4 children who got between 0 and 99 cents per tooth from the Tooth Fairy. The 1 to 1.99 group went up to 3 because there's 3 children that got between $1 and $1.99 per tooth from the Tooth Fairy, and down the list we go. This graph, as shown on the page, would actually be marked wrong, though, by me, because it is missing one of the properties of a well-prepared graph that is necessary here. It's missing a title. So we want to go ahead and put a title on this. We can call this Tooth Fairy Money, whatever you want, as long as it has a title that represents what it's about. Notice it does have labels on the X and the Y axis, so that's good. It doesn't need a legend or a key because it's only looking at one piece of data here. It's only looking at the money from the Tooth Fairy. If we were looking at how much money boys got versus how much money girls got, it couldn't be a histogram because there is no double histogram here. It would have to be a double bar graph, but if it were a double bar graph, then you would be looking at the legend or key necessary. 1 bar for the boys and 1 for the girls. All right, as we take a look at number 3 here, it says to make a double line graph of the given data, use the graph to estimate the number of CDs and DVDs sold in 2003. So as we look at our graph here, our graph has all the properties of a well-prepared graph again. We've got titles, we've got labels on the axes, we've got a key. The key is going to show me what bar or what set of data represents CDs and which one represents DVDs. As you can see, what they've done here is they've decided that the line with these filled in dots here is going to represent CDs. The line with the open dots here is going to represent DVDs, which is down here. Okay, so as we go ahead and set up our graph here, notice looking at the y-axis here, because our numbers go all the way up into the 5,000s here, past 5,000, close to 6, they've decided to go up by 500s. We could absolutely go up by 1,000s here if we wanted to make it simpler. We could absolutely do that, not a problem. Remember, if you want to skip some numbers, which we don't based on this graph because the first number is pretty low in the 700 range, but if you wanted to skip some numbers on your y-axis, you could draw that little wiggle there to show that you're going to skip some numbers and then start your numbering wherever. So if you wanted to start at 10,000 and then go up by 1,000s, which really wouldn't work for this graph, but we're just using an example. If you wanted to do that, so you could skip 0 to 9,000, you could absolutely do that. But you can't do that anywhere else but the beginning. You can't come to the middle of the graph now and do this and then say, okay, now I'm going to go to 32,000. That would be a no-no. That would be something I would not accept, nor would any math teacher. So, set up our graph here. The 98 number is just above 3,000 for CDs. So I'm going to go just above 3,000 and put a mark. The 2,000 number is roughly the same. It's gone up just a little bit, but graphically, because we're going by 500s, it's going to look much alike. So just above 3,000, put a dot. The 2002 number is at 4685, so we put a dot just over the 4,500 mark. And for the 2004 number at 5804, I'm going to go just drop beneath the 6,000 for that. As we go over to the DVDs column, because they were still fairly new, and at that time 735 is all they have here, so halfway between 500 and 1,000. Again, open dot because the DVD bar is going to have that. 1,057 for the DVD bar and 2,000, so dot right above 1,000. 3,000 for 2002, so just above the 3,000 mark, put a dot. And then the 4,000 mark, go just above it for the 2004 dot and connect your dots. The question is asking in 2003 where we'll each be at. That's this line right here. Well, this top one for CDs certainly looks like it's about 5,250, halfway between 5,000 and 5,500. This bar here, or line here rather, for DVDs looks to be right on 3,500 almost exactly. So we're going to say 3,500 there. All right, let's go ahead and take a look at the bottom here. Making a double bar graph in the check it out example here, and we're comparing the number of tickets sold in a week by boys and girls in grades 8. As you can see, the number of tickets sold is what's in the gray bar at the top there, 5, 10, 15, 20, 25. So that's what's listed across the x-axis here. We're going to go ahead and put tickets sold down here on the x-axis then, and the frequency, how many times these numbers actually pop up, which is what's right here. On the y-axis, my biggest number here is in the single digits, so going up by 1s is acceptable. If you wanted to go by 2s, you could. That wouldn't be a problem either. All right, so now we're going to go ahead and graph this out here. One bar for the boys, the lighter shade, and the second bar for the girls, the darker shade bars. Again, you need a legend or a key here because the legend is going to tell me how this graph is being read. You also have labels on the axis here. What they don't have, what they should have, is they should have a title on the graph here. So we're going to go ahead and put a title down here. The book did not do that, which would be a big no-no. We're going to go ahead and put tickets sold as a title. All right, and now we're ready to go ahead and start making our graph here. So, as far as making our graph goes, we'll get you started here, and you can see this. You've done this before. At the 0 number here, the boys sold 3 tickets, and the girls sold 4. There was 4 girls who sold that number of tickets. So the boys bar, the lighter shade bar, goes up to 3. The girls bar, the darker shade bar, goes up to 4. And make your bars. Again, the bars for this category, 0 can touch each other, but they cannot touch the bars for the 5 category, which is why there's a little white space in between there. The bars for the 5 category for the boys goes all the way up to 9, which is why this bar is so tall, especially compared to the girls bar, which only goes up to 4. That's this darker shade box you see right there. And continue on down the graph, and you'll come up with your double bar graph.